So I'm doing a PhD in London, and some of the issues I faced was that I had to rewrite a lot of code in JavaScript for some of our web apps because it's the only language that runs on the browser. And I also had some specific issues like getting data out of NCBI API and overall writing bioinformatics pipelines flexible enough for what I was trying to do. So I started writing some JavaScript code as small modules, small tools. I've put everything on GitHub. It's all MIT licenses, so you can do whatever you want with it. Has tests, continuous integration. And the cool thing with JavaScript is that you can also run it on the server or on a shell. So using a tool called Node.js, you can run the exact same code on a browser and on the shell. So here I have the tests for a parser that's actually parsing a FASTA file, gzipped, and converting to JSON. And it's the exact same code on the shell and on the browser. And the browser is even emulating a file system. So you write once and you run everywhere your code. And the other cool thing with Node.js is that it's getting quite popular in other fields. And so this is a total number of modules for each language. And you can see R at the bottom, Python and Ruby at the middle, and Node.js is just skyrocketing, although there isn't a lot of modules for bioinformatics. So I wrote a few modules, and one of the modules I spent more time writing was to access the NCBI API, because using tools, for example, like BioPython, I had to write a lot of code just to figure out where the URL for a genome assembly was. So I tried to make that more user-friendly, to be able to do simple things in one line of bash and get JSON out and pipe that data to other tools. But when I needed to do things more complex, I could use the same module inside JavaScript and write more complex pipelines. And in JavaScript, there's several ways you can organize your code. One pattern is called a callback, which simply means you do a request or you do an analysis, and when it's done, you get all the data and you deal with it. But you can also use events. So as you get in chunks of data, or as steps of your analysis are happening, you can deal with each of these steps. And it doesn't have to be in any order. So that's why it's called events. And the cool thing with events is that you can then use a property in Node.js called pipe. And so you can pipe together several modules in the same way you would pipe in the command line in bash, but more flexible. And another cool thing is that there's many projects that are building these tools to write JavaScript visually, and some of them actually support Node.js streams natively. So you can build pipelines that can run on a server, on a shell, but the same pipeline could run in someone's browser with the exact same code. So that's how Bionode happened. And the philosophy of Bionode is to provide small tools that try to do just one thing well, to provide the command line interface, but at the same time be able to run anywhere in a server, on a browser. And it has a small community around it and some collaborations with other projects, and it has also already inspired other projects. So I would like just to finish by mentioning another cool tool we recently developed in our lab that allows you to seamlessly switch between operating systems using Docker. So if you're in your terminal and for some reason a tool is missing, you can do something like switch BioLinux, and you'll be running BioLinux almost without noticing it. So you'll have the same files, everything is mounted automatically, the same user, the same shell. So the only thing that changes are the software that you're using. And once you're done, once you exit and you go back to the host OS, all the output files are where they're supposed to be. So trying to be provide a user-friendly way to use Docker. So there's a lot of details I wasn't able to talk about. So if you're interested in any of this, please come meet me later. And thank you for listening.